Here I'm going through the exam questions. The first one's fairly straightforward. Beta is acute. That tells us that sine, cosine and tangent are all positive, and so are sec, cosec and cot. Okay. We're first told that sine beta is 6/7, and we want to find cosec of beta. So we know that is 1 over sine beta, so we take the reciprocal, so 7/6. To get cot squared of beta, we want the reciprocal of tan and square that. To get tan, we need opposite over adjacent. So I've sketched a little right angle triangle. I've picked an angle for beta. I know that sine is opposite over hypotenuse, so I've put in 6 on the opposite side and 7 on the hypotenuse. We can use Pythagoras to get the third side. So 49 take away 36. I'm going to just cheat and use my calculator so don't mess it up. Gives us 13. So this must be the square root of 13. Okay, so tan would be 6 over root 13. So cot is going to be root 13 over 6. And then we want to square that, so we're going to get 13 over 36. Okay, right. The second question is a little more involved. So we are given an equation and we need to find the exact value of cos. So we have a cos here and we need to relate cosec to cos. Now we know that if we use the third letter there, cosec is the same as 1 over sine theta. Now it's squared, okay, so this must be squared as well. So we've got 8 cos theta times 1 over sine squared theta is equal to 3. Okay, let's multiply both sides by sine squared so we don't have a fraction. Okay, right. Now, unfortunately, this is not cos, but we remember from year 12 that sine squared plus cos squared gives us 1. So we can replace that with 1 minus cos squared theta. Okay, let's expand out those brackets. And now we can see we have an equation in cos. Okay, so let's move everything to one side. See, we've got, I'll move it all to the left. So we've got 3 cos squared theta plus 8 cos theta minus 3 is equal to 0. Right, I'm going to now use my calculator. Okay, and use the equation mode menu. I want a polynomial of degree 2. My coefficients are 3, 8 and negative 3. And if I solve that, I get 2 possible values for cos theta. So we've got cos theta is 1/3, that seems fine, or cos theta is negative 3. Now, we know that we can't have any values less than negative 1 or greater than 1. So there's no solution from this one, but cos theta could equal 1/3. Right. Okay, let's look at the last question of the exam questions. So we've got this fancy diagram made of similar triangles. So the information written in the question basically tells us the same as the diagram. We've got to use it to help us show that sec cubed theta is equal to 2. Okay. Right, well, sec is 1 over cos, and cos is adjacent over hypotenuse, so I know that we've got sec theta is hypotenuse over adjacent. Okay, right, so let's look at sec theta for the first triangle at the bottom there. The hypotenuse is AC, and the adjacent side is x. Okay, if we look at the next triangle, the hypotenuse is AD and the adjacent side is AC. And if we look at the top triangle, the hypotenuse is AE, which is 2x, and the adjacent side is AD. Okay, now if I can figure out what AC and AD are, I'm going to be sorted here. So let's just look at the very first bit. So I'm going to use sec theta is equal to AC over x. Okay. Now, if sec theta is AC over x, then that tells me that AC is x sec theta. Okay, right, now then, let's have a look here. We've got sec theta is equal to 2x over AD. Alright, so if we use that, sec theta is 2x over AD. Now that tells us that AD is going to be 2x over sec theta. Okay. Now the remaining thing that we haven't used is AD over AC. We could have used that instead of this one to get AD if we wanted. So let's use sec theta is equal to AD, which is 2x over sec theta, and that's divided by AC, which is x sec theta. Okay, so we can tidy this up a bit. So this is the same as, so I'm going to have to write just to the right hand side, so we've got some space. So we've got sec theta is equal to 2x over x sec theta sec theta. So the x's are going to cancel, and you can see here we've got sec theta times sec theta, which is sec squared theta. And if we multiply both sides of the equation by sec squared theta, we get sec cubed theta is equal to 2, which is what was required. Okay, right, now hence show that the ratio of the lengths ED, so that's this one here, to CB, which is that one there, is 2 to the power 2/3 to 1. Okay, so that seems a bit weird, but we know these are similar triangles. Okay, so that means the ratio ED to CB has got to be the same as the ratio AE to AB. To AC. So these equivalent sides, okay, are in the same ratio as these equivalent sides. Okay, right. Now we know that AE is 2x, and we have an expression for AC. So AE is 2x, and AC from earlier was x sec theta. But we know that sec theta is going to be the cube root of 2. So we've got 2x to x times 2 to the power 1/3. Okay, now these will still be in the same ratio if we cancel both sides dividing by x. Okay, so we now have 2 to the 1/3. We are aiming to have 1 on the right hand side. So to do that, I would need to multiply 2 to the 1/3 by 2 to the negative 1/3. If we add the powers, we get 2 to the 0, which is going to give us 1. Or you can think of it as dividing by 2 to the 3rd. So we'd have to do the same on the other side. Okay. So remember that 2 is just the same as 2 to the power 1. We are going to add the powers here, so that gives us 2 to the 1 take away 1/3 is 2/3. And on this side we get 1.